Good afternoon. Welcome to the Dallas Independent School District STEM Environmental Education Center virtual field trip. We want to say a special welcome to Marsalis, Alvarado South, Seagoville, Rolling Hills, Riley, Hotchkiss, and Cockrell Hill. Thank you for joining us this beautiful winter afternoon here in Seagoville, Texas. If you have not registered and you are watching, we'd like for you, or we'd ask that you please join us for www.tiny.cc/EEC register. And all that's for is to give us an idea of the numbers that are watching, and so we can contact you in the future if we have any information that you might need. This field trip, we'll do properties of rocks during this virtual field trip, and I just lost it. Sorry, here it is. During this virtual field trip, students will discover that the natural world includes earth materials. Students will observe and compare rocks by size, texture, and color. Mr. Broughton will tell us about tools used to study rocks. Ms. Ramirez will cover color and texture. Ms. Fuller will show us scratch test and more test. And Ms. Nash will tell us about sink or float. During the program, if you have any questions, you'll go to www.tiny.cc/EEC /question/answer and submit your questions, and we'll do the best we can to answer them. Now I'm going to stop sharing my screen. And Mr. Broughton was going to tell us about tools used to study rocks.
Thank you, Dr. Gorman. I'm going to share my screen now. Just takes a second to get my iPad paired with this computer here, but almost there. There we go. All right, you can see my little workspace here, and I have 5 rocks sitting there. The first one, this kind of pale green one, is fluorite. Next, we have granite, then calcite, then sandstone, and last, lodestone. And you might not be able to see them very well sitting where they're at. So I'm going to get out my first tool used to study rocks, which is a hand lens, and I've got it in a little holder here. But if I put up this hand lens to the iPad camera, we should be able to observe some rocks. So here is the fluorite. And you can see it's got some crystal structures. It is that pale green, but there's some white to it also. Kind of some translucent pieces, which means the light can kind of shine through it a little bit. It's kind of a pretty rock. And then next we have pink granite. It gets its name from the pink minerals in it. There's also some black parts to it, and it's kind of sparkles because of tiny crystals that make it up. So it's also a pretty rock. You see granite in a lot of homes and statues. And then here is calcite. It's another kind of crystal structured rock. White in color. And then next we have sandstone. And if you look carefully, you can see like little bits of sand that make up sandstone. And that's how it gets its name. It's because it's made out of sand that's been pressed together over the years. And then last but not least, we have lodestone, which is black. And you might be able to see kind of some little like pieces poking off of it, which I'll tell you what those are in a little bit. I don't want to say right now, but um, it's kind of an interesting rock for a special reason. But that is lodestone. So there's using a hand lens to study rocks. But whenever you study anything in science, you should also use a science notebook. That's another tool that we use in science. So here's my science notebook, and I made a little table in there, and I titled it Properties of Rocks. I'm going to name all of the rocks. So there's fluorite, granite, calcite, sandstone, and lodestone. And I'm going to record the color of the rocks, and I'm going to say if the rocks are magnetic or not. And last, I'm going to measure the mass of the rocks and record all of that in this table in my science notebook. So let's take a look at the fluorite again real quick. You can see it up close again there. It's kind of got a pale green color to it. So I'm going to write down in my science notebook, pale green. Just like that. And next is that pink granite. And that's got a pink color to it and some black. So I think I'm going to write pink and black. You could write a lot more about the appearance of these rocks, but I'm going to keep it short for now. And then next is calcite. Pretty much white. So I'm going to write down white. Then we have the sandstone. And I guess the closest color I could think of to what color this rock is gray. So I'm going to write down gray for this rock. And then last is lodestone. I guess I'll bring it up here real quick, but it doesn't really take much observation to see that it is black in color. It's pretty much pure black. So there I've completed my column for color for all 5 of my rocks. Now I'm going to take out my next science tool, which is a magnet. It's this horseshoe magnet right here that I'm going to use. And I'm going to put it up to each rock and see if they are attracted to a magnet. So nope, fluorite is not attracted to a magnet. Pink granite, not attracted to the magnet either. Calcite, not attracted to the magnet. Sandstone, no. Lodestone, yes, it is. You can see that magnet picks it up. So lodestone is attracted to a magnet, and that's what these little pieces of lodestone are. Lodestone itself is a magnet, and these little pieces of like they look like little hairs poking off of it are actually tiny bits of lodestone that are broken off, but then they themselves stay magnetic. They keep that magnetic property and stick to this big magnet. So that's what those are on this rock here. So the first 4 were not magnetic, so I'm going to write no for those. And lodestone was magnetic. So there I've completed my column for the property of magnetism for these rocks. Now I've got to move everything out of the way here and bring out my last tool, which is a pan balance. And that is used for measuring the mass of different objects. So today we're going to measure the mass of some rocks. So yeah, I've got it balanced right now. That triangle is pointing at the line. There's nothing in this pan. There's nothing in this pan. It's balanced. But if I put a rock in there, it's not balanced anymore. This rock is very heavy. It pulled this side down. So now I'm gonna have to put some mass pieces on the other side to get it balanced again. And I've got these 10-gram mass pieces that I can use. You can see how thick they are. I have some 5-gram mass pieces, about half as thick as the 10-gram mass piece. And I have some 1-gram mass pieces that are pretty thin because they're only 1 gram. We measure mass in grams. Now this rock is pretty heavy, so I know I need to start with some 10-gram mass pieces. So I'm gonna start dropping them in there. So there's 10, another 10, that's 20, another 10 is 30, another 10 is 40, 50, 60, 70, 80, and now I'm out of 10-gram mass piece, so I'm gonna have to use some 5. So 85, 90, ooh, it's getting close. It's getting close. I'm gonna switch to ones now. 91, 92. Oh, I lost the camera. There, we're back. So I dropped 92 pieces in there and it is balanced. So the mass of the lodestone is 92 grams. So I wrote down 92. Now I'm gonna do one more rock. I think we have time for one more. So I take the lodestone out, take all the mass pieces out, get my pan balance balanced again. That's pretty good. And we'll do the sandstone. That was my lightest rock. So it is heavy enough to pull that down, but maybe it's 10 grams. Let me try 10. That's actually a little bit too much. So let me take that out and do a 5, 6, 7, 8, 9. Well, maybe it is 10. Yeah, 10. 10 grams for sandstone. And that's about all my time, but I did pre-measure all of these in the pan balance. So I know fluorite is 53 grams. Granite is 48 grams. And the calcite is 51 grams. So there's my completed table for the properties of rocks. I recorded all of this in a science notebook. That's one tool. I used the hand lens to carefully observe the rocks. That's another tool. The magnet to check if they were attracted to a magnet or not, and that pan balance to measure the mass. So those are some tools you can use to study rocks. Now I'm going to pass it back to Dr. Gorman, and if you have any questions, he'll be happy to answer them.
Thank you, Mr. Broughton. And yes, the question is, are there any additional tools that you might need? And there are many, many additional tools that you can use just according to what you're looking for and where you are. Rock hammer, good idea to get what's called a field book or a field guide. It'll help you to identify many of the rocks and minerals that you might find. Here at this environmental center, we do stress safety. We really want you to wear goggles and gloves. You might even want to wear an apron if you're going to do something with something that might be messy. And you might want to test with some acid or something. So all the safety equipment that you can use, we strongly recommend that. Now we're going to go to Miss Ramirez, and she's going to tell you everything she knows about color and texture of rocks.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about color and texture of rocks and minerals. So for color, we know that we can use our sense of sight, so we can use our eyes to help us determine different colors of these rocks and minerals. And just a super quick infographic for you guys to look at. This is just a reminder of some of the different colors that we'll be looking at today with our rocks and minerals. We'll also be examining texture, and texture is simply how something feels. So we can use our sense of touch and use our hands to help us determine texture or how something feels. So let's take a look at some rocks and minerals. And as I show them to you, be thinking about their color and their texture. So how do you think they feel? Now, the one you're looking at right now is a type of quartz, and it has these beautiful crystals on the inside. Now, I can tell that the colors of these crystals are white, and they're nice and sparkly. And the outside of this rock is kind of rough, and it's a light brown or beige color. If I touch the crystals, I can feel that they're rather bumpy, and there's even some sharp crystals in there as well that can poke my finger. So this is quartz, it's our shiny one. My next one is this one. So think about the color and texture of this mineral. This mineral is iron pyrite. Lots of kids think that it's worth a lot of money, but it's not. It's called fool's gold, and it's fake gold. It looks like gold, but it's not. And it has this pretty gold color to it. And when I touch the top, it feels rather rough and bumpy, but I can actually touch these pieces here and they feel blocky. And you can even see the block shapes in these crystals here. So that's iron pyrite. My next one is this beautiful one here. So think of the colors and the possible texture it might have. And from looking at the colors here, I can see that at the tip of these little, they look like mountains to me. At the tip of these little crystal mountains, we have blues and purples. At the base of the little crystal mountains, we have yellows and golden colors. There's also some silver color in there as well. So this is a very colorful mineral here. And it's quite bumpy as well. So those rocks were described as bumpy, spiky, and sharp. But not all rocks feel the same way. So what is the opposite of bumpy? Smooth. So here's another one here. This is a mineral called gypsum. So think of the color and texture for this one. Something cool about this one, I can put my hand behind it and you can still see my hand. So you can almost see through this mineral. When I touch it, parts of it are really smooth and then other parts are kind of jagged and sharp. So this one has different textures. Another one is this one here. This one is a rather big rock, but it is super light. So that's really weird. So just because it's big doesn't mean it's going to feel heavy. And when I touch it, it feels really smooth, almost glassy. So if you were to touch a glass bottle, that's what it feels like. And it's this rich, dark black color, and it also shines in the light. So we can describe some rocks as smooth or glassy. So the next thing that we're gonna do, we're gonna take a look at some birthstones. So I'm gonna share my screen with you guys and we're gonna look at a quick little presentation. So the first slide that you're looking at is just a review of some texture words and some color words. Be thinking of those words and how you might describe some of the rocks and minerals that you're seeing today. So you might have heard me use some words, rocks, minerals, and gemstones. So what's the difference? Well, rocks are made out of minerals. So think of like a cake. When you guys eat a cake, that cake is made out of different ingredients like milk, butter, and eggs. Well, rocks are made out of different ingredients too. Rocks are made out of smaller stuff called minerals, and those minerals are made out of even smaller stuff called elements. And then when I use the word gemstones, that's just a name for those fancy and pretty minerals that people use for jewelry and art. So we're going to take a look at some gemstones called birthstones. And these birthstones are simply rocks and minerals that represent the month that you were born. And these rocks and minerals, as you can see, come in a variety of pretty colors. You might even have jewelry like rings or earrings that represent your birthstone. So as I come across your birth month, feel free to raise your hand so everyone in your class knows when your birthday is. And you'll also learn what your birthstone is. So if you were born in January, your birthstone is this beautiful red garnet, and it has this beautiful red color. Now, when people find these in the earth, when they're digging them out, it comes out like this ugly red stone here. And then a person has to actually polish and clean it and sand it to make it look like those beautiful shiny gemstones that we see. So it takes a lot of work to turn a raw gemstone into something beautiful. If you were born in, oops, I skipped one. If you were born in February, your birthstone is that beautiful purple amethyst. So look at that color and those crystals in this amethyst. If you were born in March, your birthstone is the beautiful aquamarine. So it's that kind of blue-green color. If you were born in April, your birthstone is the diamond. So these are the pictures of raw diamonds, what they look like before people clean and polish them and make them nice and shiny. If you were born in May, your birthstone is emerald and it's that dark green color. If you were born in June, like me, your birthstone is alexandrite and it's that pink or purplish color mixture there. If you were born in July, your birthstone is ruby and it's that beautiful deep red color. And again, you can see what a raw ruby gemstone looks like before it's clean and polished. And then in August, if you were born in August, your birthstone is peridot, and it's that light green color. If you were born in September, your birthstone is sapphire, and it's that beautiful blue color. I love that color. If you were born in October, your birthstone is pink tourmaline, and you can see those pink crystals. If you were born in November, your birthstone is golden topaz, also known as citrine. So think of an orange. An orange is a citrus fruit, and that's where citrine comes from. It means orange. And if you were born in December, happy birthday to you. Since we are in December, your birthstone is a blue topaz. So often, as I mentioned before, people wonder, well, why don't those rocks and minerals look pretty and sparkly like the gems in the store? So if you look at this little video, you'll see how this person is cutting and shaping, polishing, and cleaning those raw stones to make them look pretty and sparkly. So careers that people that do this, they're called gem cutters, diamond cutters, or a lapidary. They're just a person that polishes and prepares those stones to make them worthy enough to be put into jewelry. And then in our next slide, these are just some pictures of some minerals and rocks that I have. This is peacock chalcopyrite. So think of the colors that you see here. It gets its name because it's named after the beautiful peacock bird because they have similar colors. This is a random rock I found outside. I thought it was really neat because it had stripes on it, and you can see it's blue, green, and gray. This is malachite. It's a bluish green mineral. It looks pretty. This is sulfur, and it's that weird yellow color. So again, rocks and minerals can come in all sorts of different colors, not just the typical black and browns that people always think of when we think of rocks. And then here's an example of a rock collection that we have here. So think of what colors do you see and how do you think they feel? You can also quickly pick out your favorite rock and maybe describe why it's your favorite one. And then in this little video, you guys can pay attention to the video. It's about glow in the dark rocks. So you can see that those rocks look ordinary under regular light. But when you turn the lights off and put a special light called a UV light over them, they will actually glow or fluoresce, and they turn these beautiful neon colors. So they look pretty fascinating. And then in our next one, our next little slide is why do we even care about the color of rocks? And that is because animals need these rocks. They use them for shelter and camouflage. So camouflage just means they hide or blend in with the rocks. So look at this picture here. See if you can find 3 sheep and a snow leopard. They are pretty well camouflaged or blended in with those rocks. So I'm going to go ahead and show you where they are. There's 1 sheep, 2 sheep, 3 sheep, and hopefully you guys were able to find that snow leopard, and he's right here. So what do you think that snow leopard's thinking? He's trying to find him some yummy sheep to eat. And then in this picture, look at the color of those rocks and see if you can find the squirrel that's hiding in it. So this is a spotted squirrel, and it's pretty interesting that it blends in really well with these reddish spotted rocks. And there's the squirrel friend there. And then in our next picture, describe the color of these rocks and see if you can find the animal that's hiding inside of it. And it is a bird. So hopefully you were able to spot it right over here. And then in our next picture is see if you can find the animal that's hiding on this rock. And again, living things are very important for our animals to use for shelter and to hide. And there is our hidden animal there. It's a moth. So my challenge for you guys is to find 2 rocks and describe their color and their texture. So how do they feel? And I'm going to stop my screen share. And just so you know, you can find cool rocks outside in your own school or backyard. So here's one I found in my backyard. It has 2 different colors and a weird hole in the middle. I found one that reminded me of a zebra because it had stripes, black and white. This one was my favorite because it's pink and it has little sparkly white crystals in there. And then my favorite one, the heart, it was shaped like a heart and it's really pretty. So think about the things that you guys can find outside your home or at school on your scavenger hunt. We're going to give it to Dr. Broughton and Dr. Gorman, and he's going to answer any questions.
Thank you, Ms. Ramirez, for sharing those beautiful rocks with us. I've never seen so many pretty colors. The question is, what is my birthstone and what color is it? She told you that it is the peridot because I was born in August, and it's various shades of green, and it also has a hardness of 6.5 through 7. And my favorite rock, Miss Ramirez, is a rock that I got from the Loch Ness in Scotland, where the Loch Ness monster is supposed to live, but I couldn't find him. I looked for him for about 20 minutes. I don't know what happened though. I just couldn't find him. Next, we're going to hear from Miss Fuller. She's going to tell us about a scratch test and more.
Well, good afternoon, boys and girls. Ms. Ramirez told you that rocks are made of 2 or more minerals, and minerals are made of 1 or more elements. So what's a mineral? Well, a mineral is naturally occurring. It's a solid. It has a specific chemical makeup, and it's got a very structured atomic build to it, and they're inorganic. That means they don't come from living things. So we've got thousands of minerals. Well, how do we tell them apart? Now, let me show you these minerals right here. Here's one, here's one, here's one, here's one, here's one. They're all different. How can you tell them apart? Well, they have specific properties or characteristics that we can test. For example, this one's called halite. Halite has a characteristic called cubic cleavage. When you break it, it breaks into a cube every time. So if I break this, well, so I better start with the big one. Broke the big one, and it broke into a medium-sized piece. Going to break into a cube. Break it again, it's going to break into a cube. And I can tell you how you can test this. If you have a little hand lens in your classroom, mine seems to have wandered off. Oh, there he is. You can look at table salt. And all table salt is halite that's been crushed by some big rollers. And guess what? Every time it broke into a cube. So all those little bitty tiny pieces are going to be cubes. So if you want to look at that, you can see that's halite. Well, what about this other guy over here? This guy right here. This guy is calcite. Looks just like halite. Oh, halite has cubic cleavage, breaks into cubes. This is a rhombus. Calcite has rhombic cleavage. So when you break it, it's always going to break into a rhombus. So I've got a bigger one over here. Look at this. Isn't that beautiful? That's calcite. It's got 2 obtuse angles and 2 acute angles. All right. And every time you break it, it's going to break into a rhombus. We'll put those guys down. All right. Now, let's see, I'm gonna wait a minute on him. Okay, one of the characteristics is it's got an ordered atomic arrangement. And what that means is that the crystals that form from these minerals will be consistent, so it's easy to identify them. If iron pyrite is allowed to grow unimpeded, it'll form this rosette looking crystal. Isn't that pretty? That's called a peridahedron. And so that's one. Now think about quartz. I'm going to show you a really pretty piece of quartz. Crystals take a really long time to form, and the longer they have to form, the bigger they will be. This crystal of quartz was allowed to grow for hundreds of thousands of years, I'm sure. Maybe even longer than that. But each crystal has a hexagonal shape to it. That's the shape of the crystal of quartz. Well, this one is kind of a clear color. It's a little dirty because it was dug out of the ground, but it's a clear to white crystal. Well, does it come in any colors? Yes, it does. Here it is, rose quartz. Now, they don't really know why it's this pink color, but they think it's an impurity like a metal, like titanium, or like maybe gold. So, but that's what it gives it the beautiful color is an impurity that's in it. Okay, I'll show you another one. This is quartz also, got that hexagonal crystal. This is called smoky quartz. It's kind of a charcoal gray, but it's still quartz. It's got a hardness of 7, and there's some impurity in it that's giving it that dark, dark color. The last quartz we're going to look at is amethyst. Look at that. Isn't that gorgeous? Hexagonal crystals. So there's an impurity in this quartz that makes it purple, makes it amethyst. That's iron. So there are a lot of ways that you can have this, a mineral from the same family that looks very different because of impurities in it. All right, now the next one we're going to look at is called a streak plate. This is a streak plate. And if you powder a mineral, sometimes the powder will be a different color than when you have the specimen in your hand. Now, Miss Ramirez showed you a gorgeous piece of iron pyrite. This one's pretty. It's not as pretty as hers, but it is still a very pretty specimen. But when it's golden color and it's sparkly. Well, when you hit it on the streak plate, when you streak it, it will make a powder of the iron pyrite, and it's going to be a different color. So let's try that, okay? And here we go. Look at that. It looks like pencil lead, doesn't it? But it's not. It was a streak from the iron pyrite. But very often, the color on the streak plate will be a different color than the specimen in your hand. Okay, what's another way to test minerals to see what they are? Hardness. There was a real smart scientist by the name of Moh, M-O-H, and he came up with Moh's hardness scale. And it starts with the softest mineral, talc. And this piece of talc's got a pearly luster. That means the way it reflects light. And it's very soapy feeling. And it's so soft, we make baby powder out of it. Just like this, just like the baby powder at your house. And all that is ground up talcum. Okay, well, we have another mineral here. The one that Miss Ramirez had that big piece and you saw her hand, that's gypsum. Well, gypsum looks just like quartz. Well, quartz has a hardness of 7. This has a hardness of 2. Your fingernail has a hardness of 2.5. So your fingernail is harder than the gypsum. So I'm going to scratch this with my finger. And you can see right there. Can you see that little scratch mark? That was from my fingernail. So my fingernail has a hardness of 2.5. So I can tell that's not quartz. I can tell it's not calcite. Calcite has a hardness of 3. And here's a little piece of calcite. You can tell it's calcite because it's got a rhombic shape. It's got rhombic cleavage. So let's get something here that we know has a hardness greater than 3, 3.5, a little piece of copper. So I'm going to scratch it on here. And looky there. Can you see that little scratch that I made with a piece of copper? So that tells you that this is calcite because I was able to scratch it with 3.5, but when I put my fingernail of 2.5, nothing happens. So it's got a hardness of 3. So let's see if there's another one in here I can show you. Oh, let's talk about fluoride for a minute. Now this is a beautiful crystal of fluoride. It's got 8 sides. Remember, our quartz had 6 sides to its crystal. This is a very unusual shape. And this is fluorite. And this is fluorite. Fluorite comes in all the colors. It's just impurities in it that gives it the colors of green or yellow or pale blue or purple or pink, whatever the shade is. And I think I've just about exhausted my time. So I'm going to turn it over to Dr. Gorman. If you have any questions about rocks and minerals, you ask him. Have a good afternoon. Bye-bye.
Thank you for sharing those with us, Ms. Fuller. We expected you to bring out some of your big diamonds, but I guess you'll save them for a later time. And the question that came in, is there anything that is harder than a diamond? And actually there are 6 substances that are harder than diamond. I'm going to do my best to pronounce them. Dyneema. This is a very unusual one here. Palladium microalloy glass. That's all one word. There's another unusual one. Bucky paper. I got a feeling that one's man-made because 3 of these are man-made. Graphene, wurtzite, boron nitride, and lonsdaleite. Oh, that's a good one. Those are 6 substances that are harder than diamonds, but they're very, very unusual. There's not a lot of them around. And so now we're going to turn it over to Miss Nash, and she's going to do an unusual program called Sink or Float.
Hello, welcome to my classroom. So we've been learning all about rocks, and there's so many interesting ones, different colors and shapes and textures and hardness, all kinds of things. So I bet you didn't know that some rocks can float. Most people would say, no, there's no rock. Rocks can't float. Rocks will sink. But today we're going to be doing a little exploration of rocks. Some rocks come out of a volcano. We call that kind of rock igneous. That's a weird word, that igneous. Igneous rocks start out in a volcano. I made a volcano here. Let's see if it's working. What do you think? Is it gonna work? Oh boy. A volcanic eruption, run away fast, run away quick, or we burn up. Now, a volcano erupts because lava, really hot molten rock, they melted it. Melted rock from inside the earth, so it's really hot, comes out of the volcano. And once it comes out of the volcano, it starts to cool. Some of it cools in the water, ran into the ocean. Some of it cooled on land, and some of it cooled in the air. And depending on where it cooled, it becomes a different kind of rock, a different kind of igneous rock. If it cooled in the water, it becomes this one called obsidian. Yeah, one of our Black Angus is called obsidian. Look at that, shiny and sharp. In ancient Mexico, they made knives out of this. It's really sharp, obsidian. If it cooled on land, so that one cooled in the water. If it cooled on land, see that one's got little holes in it. You see those holes? It's rough and bumpy. It cooled on land, it's called scoria. And the third kind that I have here cooled in the air. Flew up in the air and it cooled in the air. And it's called pumice. And you can see it's full of holes. I've got my 3 samples here. Let's compare them. Let's use that pan balance again. We're not going to weigh them by grams. We're just going to compare them. So I've got my 2 black ones here, the obsidian and the scoria. Now, which one do you think is heavier? They're about the same size. Can you make a prediction? Let's put the obsidian right there. Whoa. And then the scoria, not even close. So the obsidian was clearly heavier than the scoria. So that's the heaviest one so far. Now let's compare the scoria and the pumice. They both got holes in them. Let's see, what do you think? Can you make a prediction? Which one do you think should be heavier? And the pumice barely even made it move. The pumice is super light. Let's see if it's light enough to float. You're probably familiar with sinking, things that sink and things that float. if we go to the swimming pool or take a bath, we have our bath toys, they float. I've got two little balls here about the same size, a bouncing ball and a styrofoam. The styrofoam is full of tiny, tiny holes. So make a prediction, this one's solid. Down to the bottom. And that one floats. So those little holes are probably one reason it's floating. Let's get our big beaker out and our rocks. So let's make some predictions. So I'm put them in. Which one do you think? What do you think they would sit in? That heaviest one, remember. The one that cooled in the water. Down to. How about that scoria? It cooled on land. And remember, it's got lots of holes in it. What do you think? Let's see. Can you see? I don't think you can see the little bubbles coming up from it. And it sank too. Now, what about that pumice? Remember, it's got lots of holes. It cooled in the air. It's not lighter than air. It doesn't float. Let's see what it doesn't float in the air. Let's see if it floats in water. What do you think? And yes, amazing. A rock that floats in water. Wow. So interesting. There's so many different interesting things to study about rocks. You can go outside and use your hand lens and observe some rocks and learn more about rocks. So if you have any questions, you can ask Dr.
Thank you, Ms. Nash, showing us that rocks will or can float. And the question is, how does a ship float? Big steel ship. And I had that same question many years ago. I spent a couple of years in the South China Sea floating around on a big old aircraft carrier and flying around on that aircraft carrier. And I often wondered how in the heck did it float as big and heavy and made out of metal, and there was 50 or 60 airplanes on it and 5,500 sailors and Marines, and it still just floated all around. And it's because of the hollow space inside the ship displaced more water, weight of more water than the ship itself weighed. Now, it just floated around, even though a lot of it was underwater, it still had no problem floating that big old huge steel ship. And now I'm going to share my screen. During this program, during the properties of rocks, the virtual field trip, students discovered that the natural world includes earth materials. Students observed and compared rocks by size, texture, and color. Mr. Broughton told us about tools used to study rocks. Mr. Ramirez did the color and texture of rocks. Ms. Fuller told us about a scratch test and more ways of identifying. And Ms. Nash told us that there are some rocks that will float. Thank you. We'd like to know how we did. If you would, go to www.tiny.cc/EEC feedback, fill out that short form, and send it back to us.